this is a runner. This is the leftover from when they mold the part. And it goes in to this thing that looks like a wood chipper. This is a grinder. Pretty much acts like a wood chipper. So if you've got the right grade of material, you can grind it up and reuse it once or twice. You can add it to virgin material. When the machine loads up with plastic, you see one line is going back to the dryers for virgin material, and the other line is coming around here. To the grinder. So the breaker is in the on position. The e-stop is in the upright position. This should fire up. But what if I push this blue button and nothing happens? What should I check? Well, the first thing I should check is to make sure that it's plugged in. And it is. After I check to make sure that it's plugged in, I'm going to go over to the service panel and make sure that the breaker is on or it's not tripped. Cycle it, see if it resets if it's tripped. Power's on. So why won't it come on? Well, I can take this key here and use it to open the door. Just turn it clockwise and the door opens. You see we've got a green LED indicating that there's power. Now I can check around for loose wires. I can make sure nothing is wrong here. The power button, start, stop, e-stop, any of that stuff. But I'm not going to go look there. I've got a green LED that tells me a lot. Go ahead and close the door, turn the key counterclockwise. Around the grinder in different places, there are safety switches. And these safety switches are two-piece. One is a switch that's tied into a circuit, wired in series, and the other is simply just a metal prong that goes in there to close the circuit. So there's one here where the hinge chute, this chute will actually pivot if you take loose this screw and this latch, and it will remove this top piece from this bottom piece, and the switch stays here and the prong goes with the chute. So if this is not shut all the way, it doesn't close the circuit. Another place is down here. You can't really see it too well, but the pan that catches all of the ground up plastic at the bottom before it goes through the hose and up into the loader, it's got to be all the way back and seated, and it should be, because there's latches up front and a big honking bolt here to hold it in place, as well as another latch in the very front of it. So if this is all the way back, the prong attached to the back of this pan will close the circuit for that safety switch. So what do we have left? Right here. Look at that, we got power. So this incomplete part here is one of the first shots they did when they were setting up the machine. You can see the outline. This is what they call a panel main. This is where all your knots and whatnot for HVAC would go for I don't know what car. But right here in the middle you can see the runner. It's still attached. These pincers called degators, they're like kind of big diagonal cutters, will cut this plastic runner off, and it'll separate the two parts from the runner. Recycle the runner, put the parts on the conveyor. There you can see that's the same kind of switch. It's a red housing instead of a black housing. It's a different brand, different part number, but they're literally the same switch. We use them for the doors on this safety cage that's made out of aluminum extrusion and plexiglass that we have around the robot and the conveyor. So there's another switch up there. If you open this door, or that back door, it'll interrupt the circuit, tripping the e-stop, causing the whole process to shut down. In the same sense, that if this switch isn't making contact, it'll shut the process down here. Here's an old switch we took off of one of the machines. We've removed the screws from the door so I can simply flip it up. You can see down in here the two terminal strips. This is where we would wire it up in series with other switches. If any one switch had an open condition, it would shut off power to the machine for safety. You can see on either side there's a hole there that's threaded for conduit. We just simply drill that out and we can run wiring through either side, both sides. The back has holes and slots for mounting. It's a fairly simple switch. Now here at the top, we've got a slot here for this prong that goes down in there. That actually physically closes the switch, completes the circuit. And this head can be removed and spun around in different positions, so you can mount this switch on a door or hatch or something like that in different positions for however you need to configure it. Now this particular prong here has a spring clip on it. They don't all have that. Some of them just have this flat base. I mean, it more or less looks like a T shape, but the prong is kind of open. It almost looks like antlers, but the prong has to push down into the slot all the way. It has to be fully seated. So if you have something with this spring clip on here, it's going to be a little bit more finicky, but if it's not down all the way, it will not complete the circuit. And that's going to make somebody look around to see, what did we leave open? What condition is unsafe? We don't want a hatch or door or something like that that has electrical or moving parts or something else that could hurt somebody being exposed. So this switch is really useful. We've got them on a couple different machines in the shop. some safety cages, things like that. It's a fairly universal switch for us.